finally, how can we convince our investor or Wall Street to invest the compound semiconductor? We depend on your marketing information. So finally, we want to invite Ms. Claire Troadec. And you can see she gave us a down-to-earth sentence. Taiwan can help. No. Can Taiwan help? Okay. Sure, yes. So let me introduce Ms. Claire Troadec. She is director of the Power and the Wireless Division of Yole Intelligence, part of your group of companies. These activities are covering power electronics, batteries, and energy management, compound semiconductors, and emerging materials, RF devices, and technologies. Based on her valuable experience in the semiconductor industry, Claire is managing the expansion of technical and market expertise of power and wireless team. In addition, Claire's mission is focusing on the management of business relationship with industry leaders and the development of market research and strategy consulting activity inside the Yole Group. Claire Troadec holds a master's degree in applied physics, specializing in microelectronics from INSA, Rennes, France. So let us welcome Ms. Claire Troadec.
Thank you. Okay, so I think it's a pleasure first to be here. Last time I came to Taiwan was 3 years ago, September 2019, before COVID situation. So it really is a pleasure to be face-to-face with you again. I won't comment all the details to come here in Taiwan between the visa, the airport, the quarantine. But again, I'm glad I could make it. So thank you for the invitation again. I think you also like me to finish the session because I think 3 years ago it was already the case. So all right, so I'm the last speaker, so it's always difficult to keep you awake, but I will try to do my best. And I had a comment. It's funny because with all this very interesting talk we had, so I'm the second lady of the day, and the other lady was a Claire, if you remember correctly the name. So my advice for you, if you want your girl to be in science, in technology, call her Claire. Apparently it works. All right. Okay, so I have, I think, a very interesting program to keep you awake. I'll try to be a bit provocative and try maybe to wake you up. So can Taiwan help in compound semi, right? So let's ask the question and let's see what are the possible answers there. All right. Before we start, just a few words. So I'm part of Yole Group now. We just rebranded the company. So former we were called Yole Development. So now it's Yole Group. And within the Yole Group, so there are different subsidiaries. So I'm now part of Yole Intelligence. Sounds very nice, like CIA. I'm Yole Intelligence, so providing market research, strategic consulting. And we also have the teardown analysis. Reverse costing is now Yole System Plus, because people are asking us, what's the link between System Plus, Yole Development? Wasn't very clear from the name. I hope now it's clear. There's Yole Intelligence, Yole System Plus. So let's make it very simple. All right, that was just for the branding. So let's switch to the topic on the compound semiconductors. A lot of things have been said. Again, I'm the last talk of the day, which in a way will ease this presentation because I don't need to re-explain what is compound semi, all the platforms. What I can say is that compound semi is everywhere. So you've seen the demonstration by WinSemi explaining all the different compound semi devices we have around us. What I want to say indeed is that compound semi is used when silicon cannot do the job, right? I think that's the easiest answer to that. So that means it's used for lighting, it's used for the lasing, it's used really to amplify signals. And you will find these wonderful materials for RF, for photonics, for lighting and display, and for power applications. Apparently it's better without the glasses. All right, so, and they are serving all the markets, consumer, automotive, so they're all around us, okay? So now if we look at this compound semi, so we have this end market application, RF, power, lighting and display, photonics, and there's really a big family of devices that are being manufactured using compound semiconductors. So RF, so we've seen some of these devices like the GaAs HBT, the GaN HEMT, so serving like the handset, of course, the base station, the radar for defense and automotive. For photonics, there are a lot of different devices, a lot of different complex structures. So mainly we're focusing on indium phosphide age-emitting lasers, indium phosphide photodetectors, and VCSELs. We've heard about the gas VCSEL. And those devices, in fact, Claire from Microsoft indeed mentioned they were originally used for telecom and datacom, and still, that was really the first market. And indeed, with the consumer boom, we've seen this gas VCSEL being implemented for 3D sensing, and now indium phosphide also entered consumer. With the latest Apple iPhone 14, I don't know if you've noticed, but indium phosphide is there now for the under the screen detection for 3D sensing. So you see really more and more of these compound semi are entering the market with some volume production. So I think this is why the industry is getting very excited, and maybe this conference is getting bigger because we see more and more of these compound semi. For power, so we are talking about silicon carbide diodes or MOSFETs, GaN HEMTs. So, and I will show you later on, that will be more or less the focus of the talk. And for lighting and display, so we are talking about gas LED, mini LED, micro LED, GaN LED, mini LED, micro LED, so serving this general lighting, display and automotive lighting markets. All right, so those are the major markets. Now if we focus on the platforms, when we talk about compound semi, again, a lot of things have been said, but just to summarize, when we talk about photonics age-emitting lasers, those can be used, those can be manufactured using bulk GaN substrates, or gallium arsenide substrate, or indium phosphide substrates. So we have different choices in terms of technology platforms. For VCSELs, mainly we see them using gas platforms. For LED, lighting and display, so depending, of course, on the color of your LED, red, green, blue, you can use either sapphire substrates where you grow a GaN epitaxy layer, or gallium arsenide substrates. And for power, if you simplify, you would use silicon substrate where you grow your GaN layer on top, or you would use silicon carbide. So those are the main platforms when we talk about compound semi, which are being used in production today. And as you've seen, they are under development for using the same platform, different components for different markets. So there's really a lot of possibilities with compound semi. Those are very exciting materials. And I say that because I'm coming from the silicon world. So it's funny. I started as a CMOS process integration engineer, and when I discovered compound, I'm like, this is so great, everything you can do with compound. But what a difficult process every time you touch compound. The manufacturing process is really, really difficult. Okay, so now some numbers. Of course, we're talking about markets, so I wanted to give you some numbers. If we focus at the substrate level, so really starting material, I wanted to put into perspective today all these compound substrates, starting materials, it's a market of around $1 billion, okay? We forecast this will grow to $2.2 billion in the coming 5 years. And as you will see here, maybe in orange, so that's really, oops, sorry, I should go back. I'm not gonna spoil all the system. Oh no, should. Yes, the laser pointer, that's this one, oh yeah. So as you see here, the majority of the market is being taken by N-type SiC substrates, so addressing the power SiC market. Then the second biggest market, really addressing the RF GaN, so this silicon carbide semi-insulating substrate, N-type here. Then we would find the indium phosphide substrates serving the photonics applications, gallium arsenide for the RF, gallium arsenide more for the LED, and power GaN with the sapphire or silicon substrates. So all those compound substrates, as you see, are really having or will apparently have a very bright future when it comes to market production. That's the substrate level view. So now if we look at who are the players in the substrate environment, so really these starting materials, of course you will find some of the big names which have been quoted today. When we talk about silicon carbide, insulating silicon carbide, of course, we need to talk about wall speed. 2.6, so now 2.6 coherent, so I use the new logo. I hope they'll be happy. So bound to be coherent with the acquisition. We're talking about Esca-Celtron, GT Advanced, AXT. So AXT more for gallium arsenide, indium phosphide substrates. So those are the American players. We have some European players, so Freiberger, SiCrystal, when it comes to GaAs and SiC substrates. In China, there are many, many players. We are discovering new players every day. But here we are more depicting the ones we think are among the leading players. So Tankerblue, targeting this, providing N-type semi-insulating silicon carbide, SiCC, and Vital for gallium arsenide, indium phosphide substrates. In Japan, you would find Sumitomo Electric, JX Nippon, Showa Denko. And in Taiwan, so here, again, my talk is about Taiwan, leading players worldwide. If I just keep it like that, it will be difficult to find names. So that's why I'm indicating the building up players. So we are seeing a lot of, some movements from the players to also play a role here in these substrate markets. So players such as Global Wafers, Hermes Epitech, WMT, TaiSiC, which has been seated by the General Chairman from Honhai, who has some shares in the company, so subsidiary of Thai Energy involved in the photovoltaics environment. So we are seeing some build-up so that Taiwan players could also maybe have a role when it comes to substrates. But the leading players are more depicted here. Okay. That's for the substrates. Now, of course, I want to add the epitaxy. So who are the players providing these epitaxy services and being able to ship epi wafers, so wafers, substrates, where you've grown this active layer of epi before you can do your device manufacturings. But then you will find some players we've quoted already on the substrate market, so wall speed 2.6 coherent. In Europe, you would find, of course, IQE with a very, very large portfolio when it comes to epitaxy, strong know-how with a lot of different substrates. Epigan, who's been acquired by Sortex, also focusing on some of these substrates. In China, you will also find some players, Ancris, also having some large portfolio. Japan is very well known, of course, for this material science, epitaxy, so Showa Denko. We've seen quite lately with some partnership when it comes to silicon carbide N-type, silicon carbide for power epitaxy. And when we look at Taiwan here, so we have strong players with API providing different epitaxy services, so for power GaN for sure, and building up other materials like silicon carbides for power applications. VPEC being a leader when it comes to gas epitaxy, and also having other possibilities in terms of materials, and Landmark also being a strong leader when it comes to indium phosphide epitaxy. Unicorn, so smaller players really building up some know-how, so more famous or more known for the manufacturing of the device for the photonics applications, and building up some knowledge when it comes to epitaxy services. So we do see some players worldwide and also some players active in Taiwan when it comes to epitaxy services. So I've covered substrates, I've covered epitaxy. Now we need to do the manufacturing. The foundry business, of course, the well-known business model in Taiwan. So I didn't want to spend time there because, of course, Taiwan is already playing a strong role here. That's really your added value in the country. So when it comes to compound semi, addressing these four markets, of course, in terms of RF devices, manufacturing, a strong know-how. So with the players we've seen, so WinSemi giving a talk. When it comes to photonics as well, a very strong know-how when it comes to manufacturing, WinSemi, WSC, Unicorn as well. When it comes to lighting and display, yes, big players, Epistar, really having a strong know-how in LED, mini LED now going to micro LED. Snow is part of Enostar, so together with Lextar. Play Nitride also playing a strong role when it comes to this micro LED, and Enostar and Play Nitride having a common investor, AUO, sorry, excuse me, AUO, very big player when it comes to display. So there's a strong ecosystem. There are strong players when it comes to the manufacturing for RF, photonics, lighting and display. But what about power? That's really what I wanted to touch for this presentation. That's a recently boomed market when it comes to compound semi, addressing the power area. Okay, so power, compound for power, namely power SiC and power GaN, all right? So let's start with power SiC. Power SiC, so you've seen some of our charts in the previous presentation, so I won't spend many time, but just to remember you that power SiC is being driven by the automotive industry, so with the electric vehicle, main traction inverter being the strong application for the implementation of SiC, with Tesla, the really innovative player making this adoption. And you will see some other interesting markets where we do forecast in implementation of power SiC devices. So it started with photovoltaics, so energy and wind also, and industrial applications also for some of the motor drives and things like that. But automotive really is the driving force when it comes to power SiC. Okay? Now if we look at the players at device level, so device manufacturing level, who are the leading players when it comes to power SiC devices? So that's a market we follow on a quarterly basis, and it's very interesting to follow. Of course, it really grew again when Tesla made the adoption, so through the technology brought by the market by ST. So ST is a big player. Then we would find Infineon strongly progressing, also having some design win with Hyundai, so we really see the progression of Infineon. Wolfspeed, of course, moving from substrate, only 5 minutes, wow. Moving from substrate to the device manufacturing, ROM as well. So if you look at these players, in fact, the market is being captured by integrated device manufacturers. So that's my message when it comes to power SiC. So the question would be, can Taiwan play a role there? Meaning, can foundries play a role in power SiC? So that's an open question. Today, the only foundry we find in this ecosystem is X-FAB. X-FAB is having some volumes, so manufacturing devices for United SiC, GeneSiC. United SiC being acquired by Covo, GeneSiC by Navitas. So, okay, there's a player here, not a Taiwanese player, but there's a foundry. Is there room for more foundries? That's the question. If you look into that today, I would say the IDMs would be the best players positioned to act as a foundry. Again, I'm being provocative here because when you look at the manufacturing of these power SiC devices, this is very difficult. And we are seeing new generations, players working on planar devices, trench devices. It is really difficult to master the technology when it comes to power SiC, which is also why we haven't seen a lot of foundries, because there's no standards. Everything is very difficult from the start. So as I say, IDMs playing the role of foundry, I'm sure they've been asked by customers. Usually IDMs playing a role in foundry, it's more in devices that do not manufacture themselves or addressing other markets, and usually it's to fill the fab. But the fabs are already quite full because we see the expansion which is happening. And another point, foundries for the power SiC. Power SiC is very difficult to manufacture, and it's also very difficult in terms of power module packaging. The packaging also is difficult. So IDMs are better positioned to address this market today, having the open channel with their customers, which is why I think it will still remain captive by IDM for quite some time. That's my take today. But at one point, of course, it's very CapEx intensive, this industry. So, of course, there might be a possibility to use foundries to get more volume, which means the foundries have to prepare now, maybe, so that in 5-10 years, they will have some market. And I think that's what we start to see. Everyone is more or less asking these questions internally. What should we do? Okay. When it comes to the conclusion, so on power SiC, what about the Taiwanese players? So we've seen on the substrates level, so we've seen players that are being active and building up experience. On the epitaxy side, so we've seen API, so working closely with Epicel for the manufacturing, so manufacturing diodes, SiC diodes, all right. serving more Asian customers, Japanese, Chinese customers. If we move to the system level, of course, you have big players in Taiwan. Of course, I mean, we are here today with the sponsor of SEMICON Taiwan, so Foxconn Honhai, really made the strong objective to play a role more and more in power SiC, in semiconductor in general, and compound semi power SiC. So we've seen the acquisition of the fab Micronics a few years ago to transition a silicon line to a silicon carbide line. As far as we understand, this is very difficult. This will take time for sure, because again, to manufacture silicon carbide devices really takes time, strong know-how, and is really capex intensive. So yes, Taiwan can play a role, but again, there will be a lot of money injected before we really see something coming out in terms of foundry business. Okay, now if we go to power GaN, then the story is very different, because in power GaN, the foundries are there since the beginning. So that's the good news when we look at the Taiwanese ecosystem. So Global Wafer also moving a little bit up in the supply chain, also building up the epitaxy know-how. We have seen, of course, so the big foundries, TSMC acting as a foundry for Navitas GaN systems, so these GaN devices players who really originally opened the door for the GaN market and really spent time in showing the performance of the devices. Episil acting as a foundry for EPC, also one of the pioneers when it comes to GaN devices. And these foundries, TSMC, Episil, TSMC can really offer foundry services for all the voltages, so focusing on the 650 volt, of course, devices, but also being able to deliver lower voltage GaN devices through the agreement they have, for example, with GaN systems. Episil more focusing on the lower voltage devices with the manufacturing with EPC. So there is a strong presence of Taiwanese players. And you can also look at the packaging. I mean, you have very strong player also in Taiwan when it comes to packaging, ASE, Tongxing. The problem is with this compound semi, there's no real standard. So yes, players can play a role there. Maybe embedded die technology can be nice. GaN packaging is really something which is tricky. GaN is a wonderful material, but really keeping the benefits of device level when you package it really takes some time, and there's no standardization at the moment, which is why it also is tricky for the big OSAT to strongly enter like that. Okay, so if we look at who are the players, as we mentioned, for the device level, and we look at the market share, so we will see the strong progression of these Navitas, all the American companies, Navitas, EPC, GaN system. We also see InnoScience, so an integrated device manufacturer based in China, having GaN on silicon 8-inch line, really strongly progressing. So not only foundries, but IDM are coming into play. And here we are not showing Infineon and the others who are really also being ready to capture some market share in this power GaN system. So the market today with foundries, but IDM are really coming more and more into play. All right. When we look at the overall market for GaN power, this time it's more the consumer that really is driving the growth for the moment. Consumer meaning volume, great for foundries, also meaning cost pressure, meaning low margin, not so great. And the future is also about automotive. We're seeing some potential, very strong potential of GaN power devices for automotive. Automotive, again, that means qualification, that means strong packaging. So again, IDMs might be best positioned maybe to serve this automotive market, given the channels they already have in place with some of the players, giving the packaging know-how they have. So really this debate between foundries, IDM, for power GaN, everybody is really looking at the technology, having internal developments. There's a strong, I think, potential or market for everyone. Yes, but there will be strong competition between foundries and IDM for the future as well. Good news is the market is growing, so there's room for everyone. Okay, oops, sorry. So in the end, so to really to conclude, What about Taiwan? Can Taiwan play a role in compound semi? Okay, I'm being provocative. Yes, of course, Taiwan can play a role. But the interesting question would be more, can Taiwan reproduce the successful story they've made with the general mainstream semiconductor? Of course, then I think it's not as easy because you've seen with this compound semi, you've seen with COVID that now all the governments have understood that semiconductor is key. So they are really putting money to really support their internal players, their local players. So yes, Taiwan can play a role, but I think that the competition between foundries and IDM will be much stronger because I don't think the IDM want their business to really go out like it happened in the past. So I think time will tell, but I think it's very interesting, very exciting to look into that. And again, the business is growing, so there will be a lot of business for everyone in the end. But there's also strong competition. Let's face it. All right, so I thank you for your attention. We have a lot of reports when it comes to compound semi, covering different materials. We'll have a status of compound semi coming up soon, so summarizing all this data. We also follow the market on a quarterly basis when it comes to power SiC, power GaN, the optoelectronics, also the RF, which is very interesting to update on a daily basis. And if you have any questions, I'll be happy to take them. Thank you.
Okay, thank you, Claire. And thank you for encouraging us. Taiwan can help. So please raise your hand. Do you have any question? Okay, please.
On the power GaN slide, why I don't see the TI?
Oops, really? That just must be my last-minute presentation preparation if I forgot to mention them. My apologies. Yeah.
Okay, tomorrow she will add it.
Yes.
No problem.
That must have been a bit crazy these past weeks, but no, it's a strong mistake if they're not there. Yeah.
Okay, if there is no any question, let us give Ms. Claire. Thank you very much. Okay, a big hand.